We are still on chapter 3, and we already covered the air pressure and the winds. And we talk about the horizontal moisture flux and air masses from frontal zones. And we're going to talk more about the storm frequency and tracks. Hopefully, we can get to thunderstorms. So the ITCZ migrates north and south, following with a 1 to 2 month lag the passage of the overheaded sun. So this figure shows the latitudinal position in February and July in 3 regions of the globe. This analysis was based on 17 years of data on the presence of highly reflective clouds in satellite imagery. Such data represent the presence of deep cumulonimbus clouds on average. The ITCZ is located at about 5 degrees north latitude because the thermal equator is displaced into the northern hemisphere due to the heated northern continents. So, storm frequency and tracks. Storm includes extra tropical cyclones in middle and high latitudes, and tropical cyclones, hurricanes, and typhoons. Cyclones are characterized by their diameter, center, pressure value, and intensity. The airflow within them is anti-clockwise in the northern hemisphere, cyclonic, and clockwise in the southern hemisphere as a result of the Coriolis effect being opposite in the two hemispheres. Extratropical cyclones are synodic scale features with a diameter of 1500 to 50 kilometers and a lifetime of 5 to 7 days. In the northern hemisphere, central pressure of mature system average around 980 to 990 millibar. Extratropical cyclone typically developed in the Lee Mountain ranges of Alberta and Colorado Rocky Mountains and the European Alps, and along eastern coastlines of Asia and Gulf Coast and the Atlantic coast of the United States. 5 storms per January move over the northwest Atlantic south of Newfoundland. So cyclones tend to form either along air mass frontal boundaries of warm and cold air in the lee of mountain ranges or beneath the eastern limb of an upper air trough where there is upper level horizontal air divergence and associated upward motion that leads to fall in surface air pressure, hence deepening the surface low pressure center. Such zones are more common over the eastern parts of the continents in winter. Cyclones decay when the upper level divergence weakens, thereby lessening the upward motion surface inflow, then fills the cyclone. Typically, several cyclones follow one another along one of the main frontal zones. The leading edge is a warm front, where warm air overrides colder air ahead of it. Behind is a cold front, marking the leading edge of cold air in the rear of the system over the life cycle of the cyclone. The cold front catches up with the warm front and the warm sector is lifted off the ground. This process is termed occlusion, and the combined front is known as an occluded front. The airflow is typically recognizes into a warm conveyor belt that transfers moist air from the south in the warm sector between the two fronts, north eastwards over the warm front in the northern hemisphere. A cold conveyor belt is a rising relative air stream from the southeast, which is initially below the warm conveyor belt, but then emerges from below and extends northward. So, a sequence of marine frontal cyclone forming a family incipient system called front fracture, belt back warm front forming T-bow, and step 4 is warm cold collusion, sea level in isobars, and satellite cloud signature, so yellow part. So frontal cyclone, particularly over the oceans, tend to develop in sequence, forming a family as illustrated schematically in this figure. So the fronts in the leading system are generally occluded, while the later ones have a more open wave form. So the analysis of surface weather phenomena is carried out by the use of surface weather maps that utilize a plotting code to display the weather conditions at surface weather stations at a given time, usually every 6 hours, 0, 6, 12, and 18 hours UTC. Air temperature, dew point, cloud amounts, and types of low, middle, and high cloud layers, wind speed, and direction, MSL, pressure, and pressure change over the last 3 hours visibly. Present and past weather conditions are all plotted using numbers and symbols. So from 1 to 9, we have a fine the weather severity. We have a fine weather in the past hour, blowing sand or snow, fog, drizzle, rain, snow, shower, thunderstorm. Illustration. This illustration of a surface weather analysis over the United States for April 30th, 2012. Warm fronts are marked by red semi circles and cold fronts by blue triangles. Both symbols are combined in the occluded front of the Pacific South Northwest. An analysis uses the pressure data to draw isobars of equal pressure, usually at 4 or 5 millibar intervals, and weather fronts. There are special symbols for different frontal types. Warm fronts are marked by semicircles pointing in the direction of movement, cold fronts by triangles, and occluded fronts by alternating semicircles and triangles. High pressure centers are marked by H and low pressure ones by low. This is known as a synoptic weather map since it shows synoptic scale weather systems at a given time. They may be continental or hemispheric in scale. Figure shows a sample weather map for the United States here. So weather maps were first constructed after the weather occurred in the 1840s to study severe storms. So when weather data were not immediately available following the invention of the telegraph, the Smithsonian Institution in Washington, D.C. became the first organization to draw real-time surface weather analysis for the eastern and central United States in the late 1840s. Although frontal analysis began in Norway in 1918, fronts were not analyzed by the U.S. Weather Bureau until 1942. Automated plotting of weather maps was undertaken in the United States in the 1970s. Now, with computers and geographic information systems, satellite and radar data can be overlaid on surface and upper air charts that we're going to see a lot during our videos. So this image shows the distribution of each hemisphere of close to 1,000 to 500 millibar thickness flows, which are low in the lower troposphere layer. These are moving at around 1,200 kilometers per day, and thus shows winter cyclone tracks in the northern hemisphere, which are seen to be closely related to the major frontal zones. And we're going to talk about the tropical cyclones. So tropical cyclones are usually much smaller than extratropical systems with a radius of 200 to 1,000 kilometers. Pacific typhoons are typically twice the size of Atlantic hurricanes. They generally form in summer and autumn at least 5 latitudes from the equator. To acquire Coriolis force to omega. So we're sinus f, where omega equals Earth angular velocity, v is wind speed, and f phi is latitude angle. Otherwise, the air would flow directly into the low pressure center. They also developed over areas where sea surface temperature exceed 27 Celsius through the rapid growth of a cyclone from a tropical wave or depression. The genesis appears to involve a warm core system within 100 kilometers wide moist air column worldwide. About 90 to 50 tropical storms cyclones developed each year. At the tropical storm stage, there are winds of 17 to 33 meters per second. It's around 63 to 118 kilometers per hour. The final stage involves the formation of an eye where winds are light and skies are largely clear. The eye has a diameter of 50 to 100 kilometers and is surrounded by a cloud eye wall. So where air ascends and by a circular bands of very high wind speeds. A Category 1 hurricane on the Saffir-Simpson scale has sustained winds of 34 to 43 meters per second, and a Category 5 hurricane has winds greater than 69 meters per second. Cloud and rain bands spiral inwards towards the eye, and the top of the storm there is outward anticyclonic airflow maintaining the uplift. Occasionally, the rotation associated with tropical cyclones leads to the generation of tornadoes. Information about conditions inside hurricanes is obtained via satellite, remote sensing, weather radar, and special aircraft resonance flights and drop sounds that aircraft release into the storm to gather pressure, temperature, humidity, and wind data as they descend and transmit the data to hurricane centers. So during the I'm going to show this one more time. That's the eye and the sand. I should show this picture earlier so you can see the eye and the outside part of that. So during each season, tropical storms and cyclones are named in an alphabetical sequence of alternating female and male names. In 2010, there were 19 tropical storms and 12 hurricanes in the North Atlantic. Tropical cyclones are primarily stirred by their average flow in a deep atmospheric layer, modified by the increase of the Coriolis force toward the poles, or the so-called Delta effect. When a stirring flow is absent, the equatorial Delta effect causes a cyclone in the northern hemisphere to move toward the northwest.